All right, in section 12.5, we're also going to talk about dividing polynomials. We did dividing with rational numbers. Now we're going to talk about dividing with polynomials. Or you can really think of these as half factoring problems. What they're going to do in these problems is they're actually going to tell you one piece of the answer, and they're going to ask you what's the other side. So let's just go ahead and start with some practice like we've been doing. Remember how to divide fractions. So that if we see a monomial in the denominator, right, it's just a monomial, that we could actually split a fraction into multiple pieces. So we could say 2x over 8 plus 32 over 8. And we simplify each of those fractions and we get 1x over 4, or just x over 4, plus 4. So 1/4 and 4. So this answer is acceptable, as is x over 4 plus 4. Oops, sloppy plus. So that's the first kind of problems we're going to see. The second are the ones where we're going to have to use long division. With long division, we're simply going to say 12, how many times does it go into 14? Once. Remember, we're reviewing process. And then we took this 1 and we multiplied times 12. Right, we always multiply this way. And then we subtract. Which is going to give us a 2. And then we bring down. Bring down that 4. And we start the process again. How many times does 12 fit into 24? Fits in 2 times. Then we multiply. 2 times 12 is 24. Then we do subtraction. And we find that we get a 0, so we can stop. Or we would add a decimal, right, to keep going. Let's look at what happens, because now that we know that 12 times 12 is 144, what happens when we have a remainder? I want to remind you of all of these pieces. So we would say, same steps, right? How many times does 12 fit into 1? It doesn't. How many times does 12 fit into 14? Once. Then we multiply. 1 times 12 is 12. Then we subtract. 14 minus 12 is 2. We bring down. That's 6. How many times does 12 fit into 26? 2 times. Then we multiply. 2 times 12 is 24. Then we subtract. And we have a 2. We don't have anything left to bring down. So we used to write our answers way back as remainder 2. Right? 2 remainder 2. Or we wrote our answers as a fraction. 12 plus 2 over 12, right? Remainder over divisor. Same thing's going to happen in these problems. Let's start working through some of these new ones. So in problem number 1, the first thing we're going to see is that the denominator is a monomial. So if the denominator is a monomial, then we can just split it into fractions and simplify each fraction. So 12x to the 4th over 3x. Oops, not plus, it should be minus. Minus 9x to the 3rd over 3x plus 6x squared over 3x. Simplify each fraction. So 12 over 3 becomes a 4, and that's going to be x to the 3rd minus 3x squared plus 2x. And that's all we have to do, is just simplify. There's nothing else we need to do. Number 2 is where things get tricky. Okay, we need to follow our processes. Same thing that we did for long division. So we're now dividing by a binomial. So we need to make sure that when we multiply, we do a full distribution, not just 1. So we ask ourselves, x times what gives you x squared? X. Now we're going to distribute. So we need to do x times x plus 3. This is our thinking step. So we have x squared plus 3x. After you multiply, you actually need to subtract. Now we have two columns we're doing our subtraction in, so we're going to do subtract, subtract. So subtract here and subtract here. So that x squared minus x squared is 0, and 7x minus 3x is 4x. After subtraction is bring down, so now we're going to bring down plus 12. And then we start it all over again. X times what gives you 4x? Positive 4. Then we need to distribute. We're doing 4 times x plus 3. So that we get 4x plus 12. And we need to do subtract, subtract. So we'll subtract in the first column and subtract in the second column. And this time we get 0 and 0. So it works out evenly. When we do that division, we get x plus 4. Now, just a few minutes ago, I told you that we could think of this as a half factoring problem. I want to show you this same problem using the box method that some of you are preferring for FOIL, because you can use that method here as well. If you don't like the FOIL method, just wait until you see the next problem pop up and you can fast forward through. But if you like the box method, let's take a peek at how it works here. So we'll use our box, and it's a half factor, half not. We start with, we know we're going to divide by x plus 3. So we know x plus 3 belongs out here. Now, the only thing we need to fill in is that ax squared piece. We just need to fill it in. That's the only one. Everything else gets figured out. So, x times what gives you x squared? Should be an x. And then you multiply. X times 3 would give me 3x. Now this b value needs to be a 7, right? We had 7x. So what else do I need? I need 4x more. And now I start over again. X times what gave me 4x? Positive 4. And then I multiply. 4 times 3 is 12. And here is that exact same answer using the box method. Let's go to number 3. All right, welcome back, box method haters. I would like everyone to give problem number 3 a try, regardless of which method. I'm going to put both of them up. So give problem number 3 a try. We'll come back and we'll talk through number 4.